Gas provides, this is UK-wide, so you have to temper it, it's not just Northern Ireland, 47% of our generation power, and 70% of our domestic heating and cooking. Okay? You have to accept that. Right? If you don't want gas, that's really fine, but which 3 days of the week don't you want the lights on, and which 5 days of the week do you not want to cook? You have to. Okay? Now, the people in the Soviet Union are providing your gas. Why don't we own the responsibility for it here if we're going to use it? Okay. What's shale gas? Well, shale gas is something which comes from a particular kind of rocks which lie underneath most of the UK, actually. Anywhere where you've got coal at the surface or near the surface, beneath that will be rocks which are probably prone to shale gas. So Northern Ireland, I'll show you in a minute. There's a picture just of the UK, but just to give you some idea, the coal measures are up here, then we have the millstone grit, and then beneath that are these shales which are laid down in deep oceans in the Carboniferous 350-ish million years ago. And they're ubiquitous because that's what the geological situation was across the whole of Europe and the whole of North America. There are some places in England, anyway, I've only got an England-Scotland map, which are particularly good for this. Cheshire Basin, offshore Yorkshire, Worcester Basin. Down here, south of London. London is not immune from this. You know, there is shale gas beneath London too. And this is a plot, excuse me, they haven't got Ireland here, I'll show you in a minute, of the main areas in Europe which have it. This is a plot of the main areas of the world which has it, and they do have Ireland on there, offshore and into the Atlantic. And this is some estimates of the amount of gas which there is in shale across the world. Now, believe me, China will not stop producing shale gas. Whatever we say here, the US already produces huge amounts. Yes, that's just a picture of the resource, approximately. So where does gas sit in rocks? We've extracted the easy gas because it sits in sandstones. Sandstones don't care if they have gas or not, they'll give it up readily. Okay? That's the North Sea. Coal, at the other end, holds on to gas incredibly tightly because it's not there as in a gaseous phase. It's bound in like a liquid into the structure. You can get it out, much more difficult. And in between there are rocks which are called shales, which have a mixture of gas and is adsorbed. It doesn't like to come out of shale very easily. Okay? It comes out of sandstone really easily. If you heat coal, it gives it up. But shale is reluctant to give it up. And that's why we frack it. This was, you might think this was the first hydrofracking which ever took place in the UK. This is Quadrilla's borehole in Lancashire in the Bowland Basin. And actually, in fact, hydrofracking has taken place in the UK since about 1996. It was a PhD of mine. We did work with BP monitoring the seismicity from fracturing in Beckingham in Lancashire. And it's been done for geothermal, it's been done for coal gas. Hydrofracking is not new in the UK. It just happens that we haven't had it associated with shale gas. Now, if you don't know what it is, this is a kind of summary of the process. You drill a vertical hole, and then you bend it round through very clever engineering into the rock so it travels horizontally. You could suck a little bit of gas out of there, but in order to produce what we call permeability, they do something called fracking. Fracking is not exploding things down the hole, it's pumping it up to high pressure, 5,000 pounds per square inch, with water. The shale reacts by producing fractures. Okay? Those fractures allow gas to flow. Okay? That's what it is. In order to keep fractures open, because if you pump the water out, the fractures would close again, you pump sand in with it, and they pump certain other chemicals in. In the US, they won't be allowed to here, but they probably will be allowed sand, water, and detergents. Okay? I have shown a slide at several of these talks with Boots biological washing up liquid. The chemicals in fracking fluid are very, very similar to that. The fracking companies want to sell it at a high price, and actually, the chemicals are really quite simple. Okay, same thing. Now, hydrofracking has taken place globally, including in the UK. Hundreds of thousands have taken place. Ross pointed out to me, probably only 20,000 for shale gas. And when that happens, these fractures give tiny little earthquakes. By that I mean -2, -1, and we use those to map the fractures. I've been doing this for 35 years with coal mining micro-earthquakes. And so you can map the pattern of where the fractures go. That's really important. And this is a plot of the Barnett Shale in the US. The top is where aquifers are. The bottom is where the hydrofractures go to. Okay? An aquifer is not a rock with water in it. It's a rock with drinkable water in it. People seem to assume that it's 10,000 feet, this is an aquifer. This is saline water. Okay? It's not potable. Potable water is this stuff here. So in order to pollute this, you have to actually have these fractures propagate up to there. So quadrillas start. I advised them to do microseismic monitoring before they started. But that was free advice, and free advice, even if it's really excellent, is rarely taken. It probably cost them several million quid not to take that advice, but that's their prerogative. They started, and on April the 1st, they had a magnitude 2.3 seismic event. That's really unknown in hydrofracturing. For some reason, DEC let them continue, and they had a magnitude 1.5 seismic event. They had about 55 seismic events. Now, let's not get too excited. Do you know the size of the seismic events we've had from mining in Stoke since Christmas? We've had a 2.5 and they've had a 1.7, both bigger than this. And how many people actually reported the 2.5? 3. Because these are not big earthquakes. I'll come back to that later. We detected that earthquake, so yeah. They want to hear. Do you want me to carry on or do you want me to stop?
Carry on, but I actually run the meeting.
Okay. You might think that.
This isn't a democracy.
Right. Yeah.
Just if you
I will.
want to make, you can come.
No, but yeah. I'm nearly finished, Basil. So these are earthquakes which we then detected with seismometers we put there. Now, they're very interesting because, in actual fact, these tell you immediately that these earthquakes came straight up into the seismometers. So within minutes of saying this, I told them these were earthquakes induced by fracturing. UK seismicity, though. Ireland doesn't have seismicity. St. Patrick took away your earthquakes with the snakes. I'm not sure why. These are bigger earthquakes over magnitude 4. They're all deep within the crust because the rocks at the surface are not strong enough to fail with that magnitude of earthquake. These are small earthquakes. The ones in red are induced by mining. Okay? Probably half of the earthquakes in the last century were mining-induced, although British Coal would never admit that. And these are tiny. Okay? These are less than 4.5. And where do these events sit? They sit down here. Okay? And this is a logarithmic scale. The biggest earthquakes have the power of about 10 billion tons of TNT. These ones here have the power of about, well, maybe 1 gram of TNT. So it's in perspective. So with others, I've actually looked at these for DEC and I've written a report as to what we should do about these. And this is what we do. If we get no events bigger than 0, right, they can proceed. If they get an event between 0 and 0.5, right, they have to take precautions in terms of actually pumping back the water so they don't carry on fracking. If they get an event greater than 0.5, they must carry out this full protocol of stopping and starting again. So that's how we will control if they fracture again. And this is, I did have a debate in press with Caroline Lucas, but the question for you is, if we want gas for the short to medium term, which I think you probably do, where are we going to get it sustainably, economically, and ethically? So you can decide.